So yes, you should let me know. Should not be afraid. So to tell me, Alex, I need to make a picture of this homework on page, whatever, in section 2.1. Fine, it is open right now, so you can make a slide, or if you want to do the screenshot, or whichever other way you like. But again, this is all going to be appearing in the recording of this today's lecture, because I'm doing the recording and I will send it to you in a little while. So it's good to realize, right? It's cutting off. Oh, that's disappointing. So what is going on? Is anybody else cannot hear me well? Please let me know. The only thing I can do is I can make my volume a little bit louder. So can everybody hear me well? Is that a problem on my side? So far there is no response. So I'm not sure. So let me know if you cannot hear me.
I can hear you just fine, Professor.
You can hear me fine. Oh, okay. Well, sometimes some people may have a not very good internet signal, so you cannot hear me very well. It's getting better, but still cuts off. So so somebody else's cuts off, but in somebody else's, some other people's, it's not. So looks like if some people can hear me well with no problems, it means that those people that cannot, or something happens, well, maybe your signal at the moment is not very good. So the question is, are you using some cell phone, or you're using some other remote connection? So maybe if you're using some remote wireless connection, try to find a location where it's going to catch a little bit better. Because yes, those are little technical things that good to be aware of, right? So it's always good to be aware of that. Maybe it's not just on my side, but it could be also on your side. But don't worry about it, because it's all recorded, so you will get the video a little later today. So you should be able to, if something is really missing, to rewind and get to that point in the recording of the lecture. Because since looks like some people can hear me well, then it's really recorded well as well. So you shouldn't be worried then about it. But once again, my internet signal is 100%. So if you hear me muffled, well, maybe try to check your volume on your computer, because sometimes your volume could not be on the maximum, right? So try to maximize your volume as well. But I guess those are little technical things that one should always try to work out whenever you're taking this online classes. So anyways, looks like 3 people sent me that they have the issues. I hope nobody else does. So, or else I could just restart my computer. Sometimes this happens when I have low signal, but my signal is pretty good. So anyways, was that exercise 17 that we did last time for a little quiz?
54, yes.
Oh, 54, sorry. 54 that deals with 17 that says not in here, not in the sample of elements that start from 1 and looks like go through 16. And looks like this is correct. So you say true, this is a correct statement, and I guess that's pretty nice question, right? I think everyone done it right. This is great. And I guess the main point of this exercise is to make sure that you get used to this word true or false, because that's going to be the idea of this chapter. We'll see true, false, as well as the next chapter, in chapter 3 especially. So the symbol of belonging, or being an element of the sample, is right here. So some elements are in the sample, some elements are not in a sample. So could be in, could be not. Well, we started to look at the section 2.2 last time, and we just barely started by, again, looking at some notation such as a subset. So we saw that part of one set will be called as a subset, and there was a special symbol for it in here. And the whole point of story is when you start to talk about your sets as elements, this is not going to be correct. So when they deal with sets, then you want to utilize this symbol. So I think this is the whole story that the section has behind it. So you just need to be careful if you're dealing with a set or if you're dealing with a part of the set called its element. So other piece that we saw here in the next section was an empty set idea. I guess maybe I'll just move to the exercises because it'd be a good idea to now start practicing with the symbols. In fact, I just saw it and go back. So here's the empty set. And that's example 3. I can highlight it up here. So in example 3, they give us a set A, which is empty. And the answer is that empty set is always going to be a subset of whatever set you can imagine. When we say that's kind of questionable. Well, you can treat it as if it was a definition. So they say that empty set, so set with no elements like set A, which I try to highlight here, is a part of any set. So if set B has something inside, well, then empty set will be a part of it as well. I say, well, you're saying it's a subset of any set whatsoever. So can I say that empty set is a subset of itself? And the answer is yes. It's also a subset of itself, which is kind of odd if one starts to think real hard about it, but it is a subset. Just as if you can look at set B, and it's also going to be correct to say that the set B, as well as any set B, will be also a subset of itself. So that's one of the interesting observations that so-called set theory will give us. And, well, one just should look at this and maybe get used to a little by little. So looks like they put this in some statements such as any set B is a subset of itself, so that's 1 here, and the empty set is a subset of B. So I would say both of those statements that they just put here are outlined in 1. So they just put commas instead of writing it twice, just like I did. So it's good to realize that these two ways to write subsets are actually same that could be treated in here. So they put commas, means and that, and that. Okay, now second part of the statement says that for any set B, the subset of it will be empty set. So what are they trying to say? Well, please notice the difference is they no longer put this equal sign. So what they're trying to say that the subset is just a part of the empty set, is just a part of empty set is not going to be correct. So you want to say that the empty set could be a proper subset or just a part of any set which is not empty. So for the empty sets, this is not a correct statement, but if your set B is any other than empty, then this is true. What does it mean? Well, example is up there. So set B could have some stuff in it. And the empty set is always a part. And we don't really care what stuff is in B, as long as there is little something, as long as B is not empty. Then we can say this simple subset without equal sign, which means a proper subset. And that was also stressed last time. So I can go to the previous page to show you this definition once again, so we can better see what is going on. So proper subset, it's highlighted here in this nice yellow box as usual among definitions that says you use this symbol that has no equal underneath, so that subset, but without equal, if sets are not the same. So if you have two equal sets, then definitely this doesn't work. So you cannot say that the set B is a proper subset of itself. It's also not true, because the sets need to be different, not equal. And that's the idea. When I say, what about A? Can I say A is not a proper subset of itself? Yes, it's for any set whatsoever. So you want to make sure that if you are talking about proper subset, this is subset which is only a part. Like, for example, here's a good piece, pair of sets with 1, 3 elements, and looks like B is bigger because it contains and 1, 3, and a little bit more. So that's what they actually have. So one can say, Alex, why do we put this with equal and without equal? Maybe we could just keep it with only one way. Well, historically, in the set theory, they have these two notations, and I'm just trying to go over those because, again, you will see them in the exercises. So I believe now it's a good time to take a look at some of these exercises at the back of the section. So let us take a look at this. So I'm looking at section 2.2. Next exercise set is here. So looks like up to practice plus, we have just problems on this page. So let me try to put them so you better see. So anyways, let me clear some room on the left side, and we can do a few set theory questions from that section. So let us start with exercise number 1. I think that would be a good start. It says, is set 1 included in this bigger set 2 or not really? How can I decide? Well, looks like I can see and first element and second, and the third element of that set 1 being a part of second, right? So I can say, yes, it is included. In fact, since the second set is bigger, then I could just put without equal sign underneath, but well, since they wanted is equal underneath, well, I can put equal. It's just like less than or equal. If you can think about this, you can say 3 is smaller than 5, right? But you could also say that 3 is less than or equal to 5. When you say, why do we need equal? It's not equal, it's smaller. Yes, but this is also going to be correct to say that it's less than or equal, right? Because or equal or less. So that's similar to say, is a part of that set or maybe the same set. But if it's not, it's fine, it's part. So that's an idea. So how about exercise 7 that says a little bit different notation, right? That says we're talking about all of the cats. So there are cats, and the other set is only black cats. So what they're talking about? Well, there are all kinds of cats, looks like. So could be red, could be black. So there are various cats, and that's my first set. I'll try to draw those cats. I'm not sure if I draw them right, but let's say those are 3 cats. So that's my first set. all cats. So let's say various cats. And then the other set is only a set of black cats. So it looks like black cats, also cats, so they're part. So the way to show it will be like that, right? So black cats will be part of set of all cats because black cats are not blue or red. When you say, well, there's no such cats. Well, but potentially one can paint the cat. So anyways, so the point of story that black cats is a part of the set of all cats, but not vice versa. So if I start to change direction of this, so if I think if a set of all cats is a part of black cats, it's not going to be true. Well, that's worth to think about, right? So the inclusion of the sets usually goes in one direction. You can actually switch its direction. So one of directions will be correct, but the other will not. How about problem number?
Can you do number 3, please?
Let's
Or
do
4?
Yeah, with those negative numbers, that's a good idea. Let's do it. So exercise number 3, again, we need to see if my first set is a part of the second. So what I do is I compare their elements. So number 3, I do see -3, which is there. I don't see a 0. I see 3 there though, but one can say, what about 0, Alice? Well, if there is no 0, then to say that it's a part of the second set would not be correct. And probably 4 will be very similar, right? So that's worth to think about it. So about 4. Well, how about 35? That is talking about subset story. Can I say that empty set is a subset of 7, 8, whatever? The answer is yes, of course, because subset, the empty set is a subset of any set whatsoever. So whatever you like your set on the right to be 7, 8, 9 to 100, or maybe just a set that has triangle in it, or maybe a set that has a box in it, or Alex, doesn't matter. That will contain an empty set in it. And that's by so-called definition. So one just needs to realize it, I guess. Empty set. When you say, what about 37 then? So can I say that pretty much in vice versa way? So is that contain an empty set? Well, nothing contained in empty set. It's empty. That's why we have it's called as empty. So definitely this stuff is not going to be part of it, or even if you try equal sign, it's not equal to empty. Empty is empty. So there's something which is not equal to empty. So I guess the exercises are pretty formal. And if one starts to think about this, there is really nothing here to worry about. So how about ones with words? How about like exercise 26? One set says we have all women, and then the other says set of all persons. So with a set of all women will be a subset of a set of all persons. And again, I think the diagram will be helpful. So if you look at the, let's say, set of women, and you can look at set of persons, so there could also be some more, right? So there could be various persons. So it looks like set of all persons has more stuff than just a set of women. So I can say women included in persons, so maybe like that is fine, because equal could be always utilized. But if we consider various persons, well, some of them are not women. That's for sure. And that's why the opposite is not working, but this is the inclusion they want. So I think those things are nice if you don't panic when you approach them. So I can try to take a look at another group of problems with actual names. And I think the point of these various exercises is to show people and convince them that it doesn't really matter what sample elements are or what the set elements are. Like in problem 41, now elements happen to be names. Okay, so names we can look at as well. So they want to do this favorite true false thing. So it looks like it is true because I can see Ralph among those 4 names since it's element. So please notice now it's a little bit different. It returns us back to the story of previous section. We are now no longer with this set, but with its elements. So distinction of this group of exercises is that we don't really have the set around it. We just have element. So is Ralph element of this set? Yes, it is. I can see it clearly right there. Okay. Now, here comes a little bit different part of the story. I want to look at exercises 43 and 45. So please notice that 43 and 45 are different questions. Why are they different? Well, because in 45, we treat Ralph as actually a set that contains Ralph. So since it's a set, right? Because they put these braces, right? Then it is going to be a subset. It's a part of the set. So it's a subset. So I can put this symbol. But if I don't have braces, if I just have a Ralph, like in problem 41, without braces, then it's element, right? It's not a set itself. I say, why not? Well, because there are no braces around Ralph. You say, that's still the same Ralph, Alex. What are you talking about? Well, we don't really care if that's a Ralph or whoever else. We care only about those braces right now. Because if we use word subset, then it refers to the set itself, so the set Ralph. If we don't have set, we have just element. Then we use different symbol. So I think the point of this group of exercises is to distinguish. Do we have a set? Well, then we use word subset. We don't have a set? Well, then we have element. So to say in 43 that Ralph is a subset is not correct because Ralph is element. So that's their point of these exercises. I know that some people will have a hard time to agree with me on this one. Well, but that's not what I made up. That's a set theory. So I'm not planning to actually test you on these things. I just want to be familiar with them for the future references to realize that there is a difference in between elements of the set, so what inside of each set, and if you take this element and put it in new set, so that'll be this one. So that's what they're talking about. So just a little flavor. I don't want to get stuck with this and just get into every single little detail of this sectional exercises. But when you start doing the homework, you're probably going to see this and might have questions. And this idea of set and a subset is pretty much all this entire section is talking about. So I think I can move on a little bit and see what else is in here. So looks like there is more exercises here on the bottom. Well, it's fine. You can disregard those. So you can just, because it gets kind of odd with all this set, subset story. All one needs to realize there are elements of the sets and their subsets. because element does not have this little braces. And that's why they designed this notation, to make sure that we can tell apart the elements and the actual sets. I want to clean my screen real quick and see what's in the next section. The next section is something that you're probably already familiar with. That's something I already tried to produce for you, so-called Venn diagrams. Venn diagrams. So those diagrams, they show you a bit of intuition into what is going on. So they just make pictures of our sets. So instead of reading all that and say U, what is U? Well, that's so-called universal set. That means it's everything. So for the figure 2.5, the entire universe, well, it's not pictured here. So let me picture entire universe. Actually, this consists of 5 elements: little square, little triangle, and then 3 more elements like a $sign, M, and 5. So that's my universe. Whether some of them in the A or not, it doesn't really matter. But our universe, or people say universal set, U, that has everything in it. So in that universe, there is no letter B, there is no letter C, there is no circle. There are just 5 elements and that's it. I say, that's a very small universe. Yes, it is. But they designed it for convenience. So that's so-called universal set. Now, in a set A, looks like we have 2 elements, and that's what they put here, square and triangle. And not in a set, or so-called complement. Not in a set A. Well, we see those 3 guys, right? They're not in a set A, but they still belong to the universe. Well, point of this is just to make one to visualize what is going on, to give intuition. So you better see what happens. I say, do they have to do this? No, but they want you to better understand it. And if you want to solve problem that is maybe a little bit more challenging, then you always want to draw these Venn diagrams. So on the next pictures on this margin, they show various possibilities that could happen here with the sets, and looks like there are 4 possibilities that we encounter. So the first one is when sets are totally separated. So people say they're disjoint, or in statistics they say mutually inclusive. So they're like disjoint sets right there. So disjoint, they're not joined. Notice the other piece is joint sets. So it could be sometimes called as intersection or overlap of those 2 sets is drawn in here. You probably saw this picture before, intersection. Well, one set could be totally a part of the other set. So we already have a symbol for this. It's a proper subset, means that A is entirely inside the set B, right? And it's not equal, it's kind of less than B. So it's entirely inside of B. So that's something we already saw. And on the third figure, they're exactly the same sets. So what people say about them, that A could be a subset or could be equal, right? But at the same time, B could also be a subset and could also be equal. So the way to use these inclusion symbols will be to show that both of them in first and the second work, then sets are exactly the same. And please notice that for the first situation, I can say that intersection of these 2 is so-called empty set. So they're totally disjoint, so there's nothing in common. And for the last, I see that intersection of those 2 sets, A and B, is here. It's nicely highlighted for us. So again, those pictures probably need not to be explained much, because when you look at it, at the picture, you right away see what is going on. So, and that's the, I guess, best thing to have. So now they trying to give you a little bit more complicated looking set. So they have some overlapping examples. And I can actually look at what they have in the example 2 and notice that there's a universal set that has them all of the elements such as letters A, B, C, D, and so forth. So it looks like they're all here from A through G. So letters of alphabet up to G. I say, what is 1, 2, and 3? Why wouldn't they actually put those? Well, they just call this as regions, so they're not really elements of the sets. They're trying to explain this better, so they probably shouldn't have put these symbols like Roman numerals on the picture because they're not elements of the sets. They're just trying to show that that's region A, region 2, region 3, and whatever's on the outside is region 4. So one can see that some regions do have elements. Actually, all of them have elements, but looks like region A, which is not intersection, has much more. And that's what now they're trying to describe. So set B, which is one that I just highlighted here, consists of 2 elements, set B. It has and D and E. Do you see that? And D, which is, looks like on the overlap, and E, just like that. And the intersection of those 2 sets looks like, if I take a look at the intersection of sets A and B, we'll have only 1 element, D. Well, please notice, since we have sets, then I have to put D in these symbols because when we have 2 sets, their intersection is also a set. So you cannot say that these 2 sets intersect only on 1 element. The set theory says it has to be set. So maybe empty, maybe not empty, but it must be set. So the set that has element D, that's our overlap, that's our new symbol intersection. Maybe I can ask you to help me. Oh, so you joined again. So do you hear anything now? I hope you do. Yes. Oh, great, great. That's great. It means mine is working, so it makes me feel good because otherwise there's no point to do the lecture, right? Nobody can hear anything. So that's disappointing. But I'm glad that you're back and now you can hear us. That's great. Sometimes it also happens to my computer though. So my internet gets corrupted and students were telling me in the other class a while ago that they couldn't hear me. And then I checked my internet Wi-Fi signal was very, very low. So I know what happened. So what I did, I moved my computer a little bit and it started to work. I was on campus in one of those rooms in the very end. So maybe the router was not sending strong enough signal to some parts of this room. Who knows? But anyways, yeah, sometimes just moving computer helps. Sometimes you might have it, it just corrupted with some programs with too much on the memory. Who knows? Because honestly, nobody knows because sometimes it's just not working. And the only way they recommend is to just shut it down and restart it over again. So anyways, I'd like you to answer me a little question for a quiz. Just based on that picture. Could you please tell me what will be inside of set A? Could you just list those elements by looking at the picture? So just tell me, is that like a D, is that like a C, B, A, whatever, G, F. So just list elements that belong to to the set A. And as usual, this is a quiz for today.